All right, you guys, get this. One of our listeners sent in notes from a conversation they had. And it's really blowing my mind. It's all about how water and light and bubbles can connect to the universe, like the big stuff, origin, structure, maybe even how it all ends.
Wow.
Yeah, right? And you know me, I love a good cosmic mystery.
It is pretty amazing, though, like how these everyday things can make you think about, I don't know, the nature of reality.
You know, so our listener, they were talking about this moment when they saw a single bubble on a stream, and it created like a star-shaped pattern at the bottom of the water.
Ooh.
Yeah, so it made them wonder, if a simple bubble can do that, I mean, what other crazy stuff are we missing out there in the universe?
Right.
Do you remember by any chance what kind of light it was? Was the sunlight hitting the bubble or?
Yeah, so the light source, it does matter.
Uh-huh.
But the really fascinating thing is what happens when the light hits the curve of the bubble.
Right.
It's almost as if the bubble turns into this like mini lens and it bends the light, and scatters it around.
So like a magnifying glass.
Exactly. It's called refraction. And it's basically when light goes from one thing to another, like from air to water, it changes direction,
Okay.
And because the bubble is, well, it's sitting right on the surface of the water,
Right.
those light rays get bent downward and bam, you get that star shape at the bottom.
So it's not even just about the bubble itself, it's where it is.
Exactly.
That is so cool. I mean, you start to see how even these super simple things can create these like complex patterns when light gets involved.
Right.
I don't know about you, but it really makes you think about the role of light in shaping the whole universe.
Totally. It's like this little observation with the bubble. It's showing us something bigger, like a principle almost.
Yeah.
This interaction between light and matter, it can lead to, wow, some incredible complexity.
Yeah.
And if we're seeing this on such a small scale, just imagine what's happening on a cosmic level.
Right. Well, for sure. Now, you also mentioned those ripples on water, making those cool circular shadow patterns.
Yeah.
You had this aha moment, like connecting that to the cosmic microwave background radiation, that echo of the Big Bang. Tell me about that.
So it all comes down to those teeny tiny changes in the water's surface. Each of those little ripples acts kind of like a tiny lens,
Okay.
And it bends and scatters the light in these specific ways,
Okay.
creating patterns of light and shadow.
Right. The circles.
Exactly. And the amazing thing is we see the same kind of thing with the cosmic microwave background.
So like those temperature variations we see in the CMB, those are kind of like cosmic ripples.
Yeah, kind of. Think of the CMB as like a baby picture of the universe, taken way back just 380,000 years after the Big Bang. And those tiny variations we see, those ripples, are actually density differences from way, way back.
Yeah.
And over billions of years, they grew.
Okay.
With the help of gravity, they turned into the galaxies and the clusters that we see now.
So we're talking about like the very beginning of the universe's structure.
Exactly. Those little ripples, they hold secrets, echoes of events that shaped the whole universe as we know it.
That's amazing. Now, in your notes, you wrote, universe is an orb.
Yeah.
Sounds like you were connecting the shape of a bubble to the shape of the universe.
Yeah, I was. I mean, it's the idea of a structure that has boundaries, like a bubble, right?
Yeah.
We can only see so much of the universe. The observable universe is limited,
Right.
And because light travels at a certain speed, well, the observable universe, at least from our point of view, it's a sphere.
So we're basically stuck in the middle of our own cosmic bubble looking out.
Kind of, yeah. And it makes you wonder, right? What's beyond the bubble? What's out there that we can't even see?
Right, I know. Okay, so this is like we're looking through a keyhole into this massive, mysterious reality.
Exactly. And this is where things get even more interesting because there's this concept called, it's called the holographic principle. And it suggests that all the information about our universe, everything we see and touch and experience, it's encoded on this 2D surface, just like a hologram.
Whoa, wait a minute. Are you saying our universe is like some giant projection?
Yeah, kind of. It's a radical idea, but it's saying that everything, the stars, the galaxies, even us, we might just be information encoded on this distant surface, at the edge of space-time. And just like the bubble's shape affects how light interacts with it, this surface, whatever it is, might be influencing the patterns we see in the universe.
Okay, that's a lot to think about. We just went from bubbles and ripples to like the idea that reality is encoded on some cosmic surface.
It is a mind-bending journey.
You also wrote in your notes, The moment we see might be an illusion, different from what's truly underneath. What did you mean by that?
Well, it's like, if this holographic principle is true, right?
Yeah.
Are we only seeing a projection, not the real thing? Is there something deeper, more fundamental that we just can't access directly?
Yeah, that's kind of what I was thinking. Like, if there is more to reality,
Yeah.
how could we even know?
You're hitting on some of the biggest questions in physics and philosophy right there. I mean, even without the holographic principle, we already know our senses are limited, right? We can only see a small part of the electromagnetic spectrum, and our brains are always filtering and interpreting things.
Okay.
So in a way, yeah, our view of reality is, well, it's kind of like a model we've built, not a perfect reflection of what's really out there.
So there's always, like, a layer of interpretation between what we see and what might really be happening.
Exactly. And that gap, that's where the real mystery is. But it's also what keeps us going, right?
Totally.
Always searching, trying to understand the universe and our place in it.
This is already way more than I expected. But, speaking of pushing boundaries, you didn't just stop at the bubble analogy. You were thinking the universe might not have started as this simple orb, but with something more complex, more, like, filled with waves.
Right.
Tell me about that.
It goes back to that baby picture of the universe, the CMB. Remember those variations, the cosmic ripples? Well, those weren't just random things, They were actually sound waves.
Okay.
Moving through what we call a photon baryon fluid. It's a fancy way of saying a super hot, dense mix of stuff.
Wait, so the early universe was, like, filled with sound. What would that even sound like?
It's a symphony we can never actually hear, but its echoes are imprinted on the CMB. But these sound waves, they weren't just passing through space, they were actively shaping it.
Okay, I'm listening.
Imagine a vast ocean, right, with waves making peaks and troughs. In the early universe, those sound waves did the same thing,
Yeah.
They created areas where things were a bit denser and other areas where things were less dense. And over time, those tiny differences, well, they grew into the galaxies and all the large-scale structures we see today.
So instead of a smooth bubble, you're saying the universe started out more like a chaotic sea of waves.
Exactly.
And that's all because of hydrogen.
Precisely. It was anything but simple, and understanding those waves, how they started and how they changed, is key to figuring out the universe,
Wow, this is incredible. We started with bubbles and ripples, and now we're talking about cosmic sound waves and the fabric of reality. I mean, my mind is blown.
And we're just getting started. There's so much more to explore. It really is amazing, that feeling you get, that sense of awe,
Totally.
That's what keeps scientists like me going. It's mind-blowing how something so simple, like seeing a bubble, can lead to these huge questions about reality itself.
I know. It's like those bubbles, those ripples. They're little glimpses into something much bigger, something we don't fully understand. And that holographic principle you were talking about, the one where the universe is like a giant projection? It's been stuck in my head ever since.
Yeah, it's a tough one to wrap your head around. But it's led to some really cool research. There's this thing called the AD-ACFT correspondence, which has given us some of the strongest evidence for the holographic principle.
Okay, AD-SCFT correspondence. That sounds pretty intense. Can you break that down for me a little?
Sure. Imagine a box, okay?
Okay.
And inside the box, gravity is doing its thing, just like Einstein said. Now, outside the box, you've got a different set of rules, different physics governing how particles behave.
So 2 different sets of rules, one inside, one outside.
Exactly. And get this, the AD-SCFT correspondence, it shows us that these 2 descriptions, they're actually mathematically the same. What happens with gravity inside the box can be perfectly described by the physics happening on the surface.
Wait, are you saying that the surface of the box is like creating the reality inside, like it's projecting the gravity and everything?
It's a wild thought, right? But yeah, that's kind of the idea, just like a hologram. A flat 2D image contains all the info to make a 3D image. In this case, the physics on the surface, the lower dimension, could be creating the reality of the higher dimensional space inside the box.
Whoa. So how does this box thing relate to the actual universe? Are you saying there's some giant cosmic box out there with our universe tucked inside?
Well, not literally a box, but the holographic principle suggests that all the information about our universe is, well, it could be encoded on a surface at the edge of space-time. Think of it like the universe is this massive cosmic hologram.
Okay, my head is spinning a bit, but I'm with you. So our 3D universe is a projection from this 2D surface.
Yeah, that's the basic idea. But there's another layer to this that you brought up in your notes, this idea of a 3D to 3D holographic universe.
Yeah, that's where I got really confused. I thought holograms were always like from a lower dimension to a higher one. How can you have a 3D to 3D hologram?
That's how we usually think about it, yeah. But some physicists, they believe that our universe's information might not be on this flat surface, but actually in a higher dimension, maybe 4D or even higher. So our 3D universe would be a projection from this higher dimensional space.
So it's not like our universe is flattened onto a surface, but more like it's projected from this higher dimension that we can't even see.
Exactly. It's a subtle difference, but it's important. And it opens up some crazy possibilities about space and time.
Like what? Give me an example. This is the kind of stuff that keeps me up at night.
Okay, well, imagine this. What if our experience of 3D space and time, it's just how our minds make sense of this higher dimensional information? It's like our brains are taking this multidimensional reality and making it simpler, you know?
Whoa. So the way we experience time, how we move through it, could be like an illusion created by this projection. That's heavy.
It's definitely a possibility. Remember, we're in the realm of theories here, right? But that's what's so cool about it.
Absolutely. It's like we're on the verge of understanding reality in a whole new way. But you also mentioned another possibility, right? That the universe could be like evolving in 3D and 4D without any need for a 2D projection. What's that about?
Right, right. It's another way to think about how the universe might be changing. Imagine a universe that's entirely 3D or 4D, no need for a surface to store its information. Everything, space, time, matter, energy, it would all be happening within these higher dimensions.
So instead of this static projection, it's more like a dynamic, ever-changing system.
Exactly. And this constant change, it could explain some of the mysteries we see, like why the universe is expanding. It could just be a natural part of how these higher dimensions are, well, unfolding.
So the Big Bang, maybe it wasn't the beginning of space and time, but just like a transition point in this higher dimensional evolution. Like the universe was never really born, it is.
That's what's so cool about these theories. They challenge everything we thought we knew. And, you know, it was your observation about those ripples that got me thinking about a more dynamic, wave-filled origin for the universe.
Oh, yeah. We were talking about how the universe might not have started out as this simple bubble, but more like this wild, wave-filled structure. It all goes back to the cosmic microwave background radiation, right?
Yep. Remember those temperature changes, the ripples in the CMB? Well, they're not random. They're proof of acoustic waves, sound waves that were moving through the early universe.
Wait, sound waves in the early universe. So the universe was like a giant cosmic symphony?
You could say that. Those sound waves came from tiny fluctuations in the early universe, and they left their mark on the CMB. It's like a recording of the universe's first song.
Okay, that's just awesome. So those patterns in the CMB, they're not just pretty pictures. They're actually an ancient recording of these cosmic sound waves.
That's right. And by studying those patterns, we can learn so much about what the early universe was like.
What kind of things can we learn? Paint me a picture of the early universe, based on these sound waves.
Well, for one thing, the CMB tells us that the early universe was insanely hot and dense. It was also surprisingly uniform, with only tiny differences in density. But here's the key. Those tiny variations, those sound waves, they're what eventually led to the formation of galaxies, stars, planets, even us.
So you're saying those cosmic sound waves shaped the universe we see today. That's incredible.
It is, and it's another example of how simple, fundamental things, in this case sound waves, can lead to mind-blowing complexity over time.
My mind is totally buzzing right now with all these ideas. We went from ripples in a pond to the symphony of the early universe.
And we're just scratching the surface. There's still so much more to uncover. What's really exciting is that we can use these insights about the universe's wave-like nature to try and predict what will happen in the future.
Oh, predictions about the future. You know I love that. So how do those cosmic sound waves help us see into the future of the universe?
Well, if we can figure out how those waves worked in the past, we can build models to see how they might evolve in the future. Think of the CMB like a giant cosmic crystal ball.
Okay, now you're talking. Tell me more about this cosmic crystal ball. What kind of future can we see?
By looking at the CMB, we can get a ton of information about how the universe started, what it's made of, and even the mysteries of dark energy. And with all that data, we can start to predict what might happen billions of years from now. Will the universe keep expanding? Will it collapse in on itself? It's a cosmic mystery.
Okay, this deep dive just turned into a cosmic thriller. We're talking holograms, sound waves from the beginning of time, and the fate of the universe. And it all started with a bubble and some ripples.
It just goes to show sometimes the biggest questions have the simplest beginnings. And that feeling you're having, that sense of awe, That's what drives us to explore, to understand, to unlock the secrets of the universe.
Okay, so I'm still thinking about all those sound waves and holographic universes. But in your notes, you kept coming back to hydrogen.
Yeah.
Almost like it's the key to everything.
It really is fundamental to the universe as we know it. I mean, it's everywhere. It's what makes stars shine, and it's the basic building block for everything else.
Right, like a cosmic Lego, right.
Right.
But how does it connect to everything we've been talking about? The waves, the circles, the structure of the universe. Seems so simple to be so important.
Well, think back to that early universe that we were describing.
Yeah.
That hot, dense mix of stuff, the plasma. It was mostly hydrogen, a swirling mix of protons and electrons. And it's because hydrogen was, well, it was dominant, that those cosmic sound waves could even happen.
Ah, so hydrogen wasn't just there. It was like the stuff that those sound waves traveled through. So without hydrogen, no ripples, no structure.
Exactly. Imagine trying to make waves in an empty pool.
Right.
It wouldn't work. Hydrogen, it was like that cosmic pool. It let those waves move around, and ultimately they shaped the universe into what we see today.
So hydrogen is like the universe's first architect.
You could say that. It's pretty incredible to think that something so simple, so common, played such a huge role.
Yeah. It makes you wonder, if it was that important in the beginning, what's it doing now? You also mentioned that hydrogen is connected to a medium in the universe. What did you mean?
This is where things get a little, well, speculative, but it's a really interesting idea. Imagine hydrogen everywhere in space, in all its different forms, acting like a cosmic medium connecting everything.
Okay, so more than just a building block, it's like a network. But how would that even work?
Think about how sound waves need something to travel through, like air or water.
Okay.
What if hydrogen acts like that, but on a cosmic scale, like a pathway for energy and information to flow throughout the whole universe?
So it's like the glue holding it all together, the network that everything communicates through.
That's the idea.
Yeah.
And maybe this interconnectedness could explain why we see these patterns, circles, spheres, waves, everywhere. Maybe they're a reflection of how hydrogen works with the fundamental forces of nature, shaping space-time itself.
I'm starting to see hydrogen in a whole new way. It's not just a building block. It's like this active force shaping the universe.
Yeah.
It's like those bubbles and ripples. They led us to this whole hidden network.
It's amazing.
And this brings us to your last point, the idea that hydrogen, it could be the key to understanding not just the past, but the future of the universe, too.
It's a bold statement.
It is.
But I think you're onto something. If we can truly understand hydrogen in all its forms, I think we can get a much clearer picture of how the universe came to be and where it might be going.
So hydrogen is like the Rosetta Stone of the universe.
That's a great analogy.
It holds the secrets of the universe's past and future.
It really might.
This whole deep dive has been amazing. We started with bubbles and ripples and light on water, and somehow we ended up exploring these crazy ideas, holographic universes, sound waves for the Big Bang, and hydrogen. Who knew it was so important?
It just shows you the power of observation and asking questions.
Totally. And for anyone listening, remember, it's those everyday things, the stuff that sparks your curiosity, those are the things that can lead to big discoveries. So keep looking, keep asking questions, keep exploring, because you never know what amazing secrets the universe is waiting to reveal. And that is a wrap on our deep dive for today. Until next time.